Hey everyone, so today I'm going to be covering the classwork for May 11th. We're doing more triangle congruency, so we're going to do more triangle congruency throughout the week. What I've done here is I've posted 3 videos I want you guys to watch before we start the problem set. Um, I think the first one is just reviewing SAS congruency. So this problem set actually just focuses on SAS, side angle side, just that. So the one video reviews that, the other one is kind of like a song that you might find annoying. If it's annoying, just turn off the volume. Um, it'll show the lyrics. But it reviews transformations, which are basically rotations, reflections, and translations. Basically, how you move something in mathematics. So without changing the size. So that's what the next one will be, and then the next video will kind of put that into context of congruency. So it's really important you watch these first 3 videos before we get into the problem set. Either watching it with me or doing it on your own. So just make sure you watch these videos because I think otherwise this will be hard to follow. And again, take notes and you'll send me your notes. So what I'm going to do is I'm going to do this first problem here. But first let's see what it's saying. It says we got to complete the following problems on a separate sheet of paper. Justify whether the triangles meet the SAS congruence criteria. Explicitly state which parts of the sides or angles are congruent and why. If the triangles do meet SAS congruence criteria, describe the rigid motions that would map one triangle onto the other. So that's what what these videos up here will be useful for, is this second part. I think you guys know kind of what SAS is and how to do it, and what the congruence criterion are. This will just explain it in terms of transformations. So I'm going to do this first problem. I think I'm going to do the third problem. So let's see. I'm going to grab the number 1 right here. Okay. So given that side AB, I think the first thing to do is what does this symbol right here mean? 2 lines like up and down like that means parallel. So it's saying that AB is parallel to CD, and that's the same thing as this little caret thing. So we know that these 2 sides are parallel. So they already have the little caret thing that indicates they're parallel. Parallel means that if this line went on forever and this line went on forever, they would never touch. And it says that AB is equal to AC. So that's what this line here means. So we know that. Now it's asking, do ABD, so does ABD, so that's this triangle, does ABD, is it meet SAS criterion with this other triangle, with CDB, so CDB. So is this triangle congruent with this triangle? And they kind of share a side here. So that's really useful. So what I'm going to do is, normally I do this like the multiple choice format, but all this one is asking is, it just wants to know, is it SAS? Is it SAS or is it not congruent? So let's see. First off, we were given that AB equals CD. So the distance from A to B is equal to the difference, is equal to the distance from C to D. So the first thing I'm going to do is I'm going to highlight this side. I'm going to highlight this side in purple. Other things to note. So let's see. Let's make this green. Other things to note is we have a shared side. Whenever you have a shared side, that means that the side is the same for both triangles. So I'm going to highlight this right here. Now the next thing is, doesn't meet side angle side criterion. So is this, basically what that means, for it to be SAS, that means that, let's see, that means that this angle would have to be the same as this angle. So is that true? And the only reason we know that's true is because they gave us this information, that AB is parallel to CD. So because AB is parallel to CD, we know that by alternate interior angles, so A, alternate interior angles. We did cover this before school. one out due to the COVID pandemic. But just as a review, if you have two lines that are parallel, so I'm going to add that little caret thing, two parallel lines that are cut by a transversal. I'm going to draw my transversal. Transversal is just a line that intersects two parallel lines. That means that this angle here will be equal in measure to this angle here. So if this angle is 35 degrees, this angle will be 35 degrees. That's all it means. You can kind of see how that plays out in this problem. So that means that this angle is equal to this angle. So that means we have side, angle, side. So purple, maroon, green, purple, maroon, green. So side, angle, side, angle, side. So this one is SAS. So I'm going to put that over here. SAS. And the other thing it has to do, remember, is we got to say, describe the rigid motions that would map one triangle onto the other. That's a little bit harder to, we haven't really covered that too much yet, but I'm going to try and show you guys. So for that, I'm going to erase what I've got over here. So we've established that these two triangles are congruent. Now, let's see. That'll do. So how are we going to prove that, basically, for triangles to be congruent, we should be able to put one on top of the other. So it's hard to sort of explain it. If I were in class, I'd be able to kind of cut it out and really show you guys. What I'm putting here is I'm putting a dot. This will be the center of rotation. So if I were to rotate, how about if I were to rotate triangle CDB, so CDB, around this point here. Let me just kind of show you what it would look like. Basically, this C would come all the way around to here, to where A is. The B would come all the way around to where D is. And this point right here would come all the way around to B is. So basically, if you rotate this around this point here, if you rotate it 180 degrees, it'll map one triangle onto the other. So think of B, it's going from here to here. That's a 180 degree angle. So let me just erase this one. So you see how this would make 180 degrees if this were like the angle opened up here as 180 degrees. So if you flip this triangle all the way over, you end up mapping out the triangle on top of itself. Okay. So we're going to say 180 degree rotation about. And how do we describe this point that I put there in green? That point is halfway between B and D. So I'm going to say the midpoint. Midpoint means the point in between 2 points, exactly halfway. About the midpoint of BD. About the line BD. So the midpoint of this, if we rotate this triangle about this midpoint, it'll end up being on top of this triangle. So that's how you know it's congruent. So part 1 is just saying SAS, yes, it's congruent. And part 2 is this piece. So that's what I want you to do with these problems. First, you're going to say whether it's SAS or not. So you can say SAS, or you can say, for a different problem, if it wasn't SAS, you could say not congruent. So this one, we're only looking at SAS today, not looking at ASA, not looking at side, 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 SSS, not looking at HL. We're just focused on SAS. Okay, I'm going to go through the next problem real quick, which is, I'm going to skip 2, I'm going to do number 3. So again, we're just focusing on SAS. So let's look at the given information. Let's see what we can do with this. So, given that KM and JN bisect each other, does triangle JKL and triangle NML meet SAS criteria. So if they meet SAS criteria, that means they're congruent. So this is asking, are they congruent by SAS? So basically what it says is that KM, which is this line here, and JN, this line here, they bisect each other. So if you remember when I taught you guys what a perpendicular bisector was, that means that it's a line that cuts itself in half at a perpendicular one. This is just a bisector. So if this line and this line bisect each other, basically what that means is that this line, the line in green, let's see, will bisect the line in purple. And also, because they bisect each other, the line in purple will bisect the line in green. So remember, we got two triangles here. I think what's important is that if this is bisected, if the green thing is bisected, that means from here to here is the same as from here to here. And that'll mean that what's from here to here, if this is if the purple line is being bisected by the green line, that means that this will equal this. So I'm just adding the tick marks here, but do you see that this purple and this purple, because they're bisected, if two things are cut in half, that means the two halves are equal because they're half of the original. So that means that purple is equal to purple, green is equal to green. So what we got here is two sides, and now we just got to know, are these two angles the same? Because we know we have to have SAS. So for that, does this angle, is that equal to this angle? And yes, they are, because those are vertical angles. Whenever you have two lines that intersect, angles that are across from each other will always be equal. So if this was 30 degrees, this over here would also be 30 degrees, no matter what. So this angle here has to equal this angle here. So yes, this is congruent by SAS. I'm going to say yes. So yes, by SAS. So now remember the last part, I'm going to try and get through it pretty quick. We got to say, if the triangles do meet SAS criteria, describe the rigid motions that would map one triangle onto the other. So for that, I'm going to erase what we have here. How do we get this triangle on top of this triangle? So I'm going to try and do a sketch here. What you might think is that it's some sort of a reflection. But remember that if you had a reflection, you would reflect this over. This K would end up here, somewhere like here. And then this J would end up over here. So you can see the purple triangle I'm drawing right now does not match what I'm trying to reflect it over. And again, I'm a little bit sloppy here, but you kind of get the idea that J won't match up with N. So what we actually have to do is, we know it's not going to be a reflection. Can you just slide this over? That would be what a translation is. Can I just slide this thing over? And I feel like you can kind of picture that if I did that, even if we slid it down, it wouldn't quite match up. If we slid this over, we'd have something like this. If we just slid this triangle over, and we know that won't match up either. What we can do is we can do a 180 degree rotation. So I can take this and rotate it so that this triangle, basically the whole thing spins. Picture the whole thing pivoting around L. So this whole triangle moves, and then it would kind of match up like that. So what we would say is, transformation, it would be a 180 degree rotation about L, about this point L.